Okay, we're going to get started because I hope we can get to the Q&A on this one. So our next session is a panel discussion about air navigation service provider integration plans and the issues that will need to be addressed when integrating RPA into the ATM system. Our moderator for this session is Ms. Leslie Cary, Chief of the RPAS section at ICAO. In this capacity, Ms. Cary is responsible for coordinating the development of ICAO standards and recommended practices, as well as guidance material on all aspects of RPAS. Ms. Cary has been leading ICAO's work on unmanned aviation for over 10 years. She has served as the founding secretary of the UAS Study Group, the group of experts which pioneered ICAO's work on RPAS, as well as its successor group, the RPAS panel. Prior to joining ICAO, Ms. Cary worked as an air traffic controller with the FAA for many years. Leslie, it is a pleasure to invite you to the podium to lead this discussion.
All right, thank you, Phil. And good morning, everyone. And welcome to this ICAO and Sichuan province event. It's great to be here with all of you, and I hope you will get a lot out of this. Now, ICAO agreed to undertake work on UAS back in 2007. At that point, there was very little work that had been done on certainly the global scale, although there were increasing numbers of military, in particular, unmanned aircraft, but they really had not spread into the civil arena. However, people did understand that they would come into the civil arena in larger and larger numbers, particularly as the standards were developed for them. So that's why ICAO got involved. Now, originally, it was assigned at ICAO into the air traffic management section, and I just happened to have been the person who arrived at that point in time, so it was assigned to me with a go figure it out direction. Now, all of the initial analyses indicated that ATM was really kind of the final stage of what we needed to be looking at. We were so used to ATM being closer to the forefront with manned aviation, but that's because manned aviation has been around for such a long time, and the changes occur incrementally. A particular new aircraft is introduced, such as the A380, which drives certain changes to the system, but all the fundamentals are already in place. Regulators know how to evaluate the design of aircraft and determine whether or not they will be airworthy. Everybody knows how the system works and what kind of technology is required for aircraft to fit into the system. So the changes are incremental in manned aviation. But this new advent of the current unmanned aviation world is happening all at once. So we have to step back and look at this from the very beginning and try and figure out what all the underlying requirements are, the fundamentals, starting with things like airworthiness and licensing and operations, all of which have to be in place in order for the air navigation service providers to provide adequate service to these aircraft when they're operating in the airspace. So it was a big step back to look at all of these things, but at the same time, we cannot be pretending that we're starting with a blank piece of paper when it comes to regulating unmanned aviation. It has to fit into the system, and that system is managed to such a large extent by the air navigation service providers. And of course, I can say that as an air traffic controller. We know that we're always in charge of these things. So we have to look at the end product. Where will these aircraft fit into airspace? How will they operate in the airspace? What are the requirements that they have to meet in order to operate in the airspace? And who better to explain those challenges for us than a group of air navigation service provider experts. So with that, I am going to introduce the individuals of my panel one by one. We are going to start off with Mr. Nico Voorbach, the Director of the ICAO Affairs at CANSO, the Civil Air Navigation Services Organization, who represents ANSPs from around the world. And Nico will come fill us in from the CANSO perspective on some of the challenges being faced as we're looking to integrate RPA into airspace. Nico.
Thank you, Leslie, and thank you for ICAO to invite us in this very important event. So we're going to talk a bit about integration of the RPAS in the ATM system. And I want to ask some fundamental questions. Are we ready? Or better yet, will we be ready when they come in en masse, when we see this morning talking about in about 2 years it will be growing very fast with cargo operations. So the question is, are we ready? What do we need to do to get there? Do we have enough resources to do it? Are the states around the world already prepared for what is coming? So what do we need to have those systems, the RPA systems, really integrated into aviation? We need good regulations. And of course, that's where we're working on with ICAO, with the states, with the civil aviation authorities. We need to have airworthiness standards. As Leslie said, they're not there because there are so many different systems around the world with different requirements, with different possibilities. We have to be ready to have those airworthiness standards, and we have to define the training standards that go with it. And that all has to be ready in regulations when we start to fly there in international aviation. I will go further a bit about airworthiness. That was already talked a bit also this morning and yesterday. What do you need to have an airworthiness requirement on the remote piloted aircraft? Training is one of the other important things, and it's not just training of the remote pilots, but it's also training of air traffic controllers, training of the civil aviation authorities who do the quality control and the safety measurements. So that all comes into the training part. If we look into the regulatory effort, we know that everybody is very busy, very hard working on it. And I just put some small things that are around the world, but every state is more or less looking into it. And also the regions working together are getting the regulations ready. But if we see how fast it's growing, if we see what is coming, if we look at the diversity, my question to you all and my question to the regulator is, will we be ready when this really becomes effective? Will we be able to maintain our safety record that we have because we are prepared in the way that we should be prepared to have this new entrance into our system? ICAO is working hard on this and doing very well, and as Leslie said, started in 2007. We now have the RPAS panel who's meeting 3 times a year, which is extraordinary for an ICAO process that you meet a panel more than once a year, 3 times a year, is really showing that ICAO is really seeing how much has to be done and how important this issue is. But do we have enough resources to really get the regulatory framework ready for international aviation? Getting an airworthiness process is not very easy because you have to go through several steps, and this is just an example of how to go through it. And all the time you have to put the risk assessment into the whole system. If we do not do the airworthiness process correctly, we might get accidents, and accidents will push back the whole system. If we see what happened to the unmanned cars when there is a small accident, it was worldwide news. The same will happen with the remote piloted aerodrome system. If we want to support the system, and we have to support the system, we have to make sure it's safe, secure, and really fits into the system and not deteriorate the safety standards we have at the moment. We have to go through a whole process flow. We have to see how we can get the risk management into it, and if we are ready really to build the remote piloted systems as they are required by the regulatory process. It should be risk-based, but it should not be too rigid to frustrate or stop the process of these things, because as we saw before, like the founder of Boeing said, it is something that we have to do. It's a new era, we're going forward, and we cannot say it can be done. We have to find these solutions. But always, and that's what one of our, as CANSO, main prospectus, but for the whole aviation is, safety must always be the #1 priority. I want to talk a bit about training. We already had yesterday a whole discussion about remote piloted training. And yes, licensing is important. Maintenance is important. If we see how rigid the maintenance of our aircraft is, do we need something like that also on the unmanned systems? Have we even thought about maintenance certification? We have to get forward that. Air traffic services, and I come back to that in a moment, is very important. If we don't have a pilot to talk into the unmanned aircraft, how do we know how it's operating? How do we communicate? It must be in a way developed that the qualification and certification is also well monitored by the responsible states, that they really know that the remote piloted or the air traffic controllers are capable of dealing with this system in an already very complex and crowded system. Because in 15 years from now, aviation will be doubled. And that is just civil aviation, normal aircraft operations. If we put there also the unmanned systems, will that not overflow? And will everybody be trained and ready to do that? I want to go back a bit on the facts of the air traffic services. What is very important for us is what will it take to get into there from our perspective as the world's representative of civil aviation authorities, the air navigation services providers. It should be based on a proven training and safety strategies. We do not have to develop everything new. We have to look at what we have, and we have to adapt it to the systems that are now being developed, taking into account the complexity and the diversity of all systems. We must have good contacts with the manufacturing, and the manufacturing programs and processes should maintain in a way that is, but it also should be coordinated with the regulatory bodies so that they know what to develop on the safety issues and the regulatory framework. Timeline is important, but if we see how the timeline of the whole development has been pushed up for the last 10 years, we thought it was very slow, we thought we had our time. Do we still have time? Do we have to keep up our pace? I want to highlight one thing into the communication part. As I said before, normally an air traffic controller talks to a pilot. With unmanned systems, that might not always be possible. What we see as CANSO, as the civil air navigation service providers worldwide, is a problem. How do we recognize that a remote piloted aerodrome system doesn't have communication anymore with its remote pilot? How do we recognize that this system is not being controlled anymore from a distant union? For civil aviation, we have several codes in our secondary surveillance radar systems, in our transponders. But if command and control is lost from an RPAS, we do not have a system that automatically from that unmanned system comes and shows air traffic control it's not being controlled anymore. Therefore, within the RPAS panel, it has been discussed a long time already, what kind of code could be automatically be generated by the system if we have a loss of control or a C2 link, lost link situation. We have codes on the transponders of 7700, which says there is an emergency on board of an aircraft. We have 7600, which says the pilots cannot communicate anymore with air traffic control, but that's not really a C2 link. And therefore, there is discussing about a special link like 7400 that automatically be generated from the unmanned system to get the attention of the air traffic controller that this unmanned system is not anymore controlled. And we think that is one of the essential things, and that's also why it was discussed and more or less approved within the RPAS panel that there should be a unique code coming from the aircraft, and 7400 seems to be the most likely outcome of that. Next month in ICAO there is the Air Navigation Conference, where the states, the member states of ICAO will make decisions regarding the future of the regulations and things in ICAO, and we will have put a paper forward requesting the member states and ICAO to develop such a code, an automated system in the RPAS, in the unmanned systems, that they should bring that forward. It's basically, in the 10 minutes that we have, the importance, what we see in the aviation regarding the integration and what is needed, and the challenges we have to get the unmanned systems safely into our air navigation system. Thank you.
All right, thank you, Nico. Next, we will hear from Dr. Francis Schubert, the Chief Corporate Officer from Skyguide, Switzerland, and also a professor at various locations. So, Dr. Schubert, please.
Thank you, Leslie. Good morning, ladies and gentlemen. First of all, I'd like to thank ICAO and the People's Government Decision Province for the opportunity to address this symposium. I wish to use my 10-minute introductory statement to share the perspective of one European ANSPs. I don't plan to comment my slides in details, but I would rather outline a few key messages. From an interaction with ATM perspective, drone operations can roughly be divided among three categories. There's first the very high altitude above the ceiling of manned civil aviation operations. Then there are operations in the intermediate airspace layer presently used for civil aviation activities. And then there are operations in the very low altitude of the airspace. Our initial assumption as an ASP was that the layer that would require the most urgent regulatory attention was the intermediate shared level of the airspace. But over time, we've gradually come to the conclusion that the segment that will require the most urgent attention is actually the low altitude segment. And why does the US traffic management, or the UTM, matter from an ANS perspective? Well, first, obviously, there is a need to integrate drones in the airspace where we want them to operate, and to keep them away from those areas where we do not want them to fly for safety, security, or privacy, or any other reason. Then you can say that the U-space is a new area that opens new business opportunities for NSPs, but above all, we believe that the UTM has a massive laboratory potential. The European ANSPs are aware that accommodating the massive expected traffic growth over the coming decades will require a significant increase of the system's performance. And the last significant capacity breakthrough was probably the introduction of the reduced vertical separation minimum, and it's difficult to identify the next game changer that will allow the delivery of more performance. So we believe that the drones can and will act as a disruptive factor in the most positive sense of the term. We believe that the U-space offers an opportunity to experiment functionalities that are too difficult to test in the classical ATM world, and that these functionalities, once they're brought to maturity in the unmanned aviation world, can then be exported into the ATM system, for instance, to automate some of the processes. There's a consensus that a robust regulatory framework is required, both to support the development of drone operations, but also to mitigate the risks involved. What presently exists in most parts of the world is embryonic and unfit for the purpose. In Europe, for instance, in many countries, the only hard regulation that exists is the so-called 5-kilometer rule, meaning that no drone is allowed to fly closer than 5 kilometers from an airport without authorization, and that applies to all drones regardless of their purpose. And this rule applies, for instance, in Geneva Airport in Switzerland. The airport is located 4 kilometers from the city center. And if you apply this rule strictly, it means that every kid in town who wants to fly his drone will need to call the control tower for permission. Do the kids call the control tower? No, they don't. Do we want them to call the control tower? No, we don't want them either. So this is a regulation that is neither enforced nor enforceable. What is needed is a set of rules that are much more surgical and really address the risks involved. We've heard that the drone industry is well ahead of the regulatory framework, and it's a good thing that operational, technical, and business considerations are leading the development of the regulatory framework, but the gap is becoming worrying. The drone industry likes to compare the development of their activity to the birth of the internet, but we heard from Leslie in her introductory statement there's a fundamental difference in the sense that the internet developed in a vacuum, whereas drone activities develop in an environment that is already occupied by manned aviation. So this panel is about the need to address from a regulatory perspective, and one of these issues is the necessity to account for the fundamental difference of cultures between the manned aviation world and the drone industry. These differences are massive, and I don't have time to comment these in details, but the bottom line is that the drone industry has a different approach to regulation. Like most highly innovative businesses, it simply moves forward and implements until the regulatory authorities have no other alternative than to formalize what has been put in place. One reason why the regulators understandably struggle to develop a regulatory framework is that there's presently no common reference model for what a UTM system should look like. It's often argued that there's still too many open questions before a regulatory framework can be developed, but our view is that it is, and it will remain the nature of the industry to move very fast, and that new questions will arise more quickly than the old ones are answered. So we believe that there are presently enough key features identified to allow for the development of a core UTM model that is sufficiently reliable to outline the core of a future regulatory framework. This assumes that the regulatory process must be empirical. The regulatory framework will therefore need to be simple, focused, and to be sufficiently flexible to adapt to unforeseen developments of the drone industry. Another essential requirement is that the framework must be light. The UTM offers unique opportunities in the sense that drone technology can act as a powerful substitute for hard, detailed regulations. And what we mean by that, our favorite illustration is an anecdote we like to share, and it occurred in November 27. Skyguide had organized a corporate event, the purpose of which was to demonstrate to the public the capability of drones. The event took place at the National Football Stadium, and we had invited a wide panel of representatives from the press, television, as well as several drone operators. But one element we had not factored in was that the event took place less than a week after terrorist attacks in the city of Paris. And as a consequence of these attacks, the European police authorities had enacted a ban on all drone activities at and in the vicinity of football stadiums, but that restrictions had escaped us. So when the time came for the drone operators to fly their devices, they switched their drones on and nothing happened. Not a single propeller turned. So no one understood what was happening. The operators fiddled around with their drones for 5 minutes until one of them called the manufacturer's hotline in China. And the manufacturers explained, well, you should know that the police authorities in Europe have forbidden the operation of drones at football stadiums, so we have force downloaded the coordinates of all football stadiums in Europe, and you will not be able to fly your drone as long as the ban is in force. So now going back to the need for a common reference UTM model, in 2017, last year, Skyguide took the initiative to outline a proposal of what such a model could look like. And here again, I don't have time to enter in a detailed explanation, but we looked at the possible functionalities, the infrastructure requirements, the use services to be offered, as well as the role of the various stakeholders involved. On that basis, with the support of major players that included AirMap, SenseFly, Intel, CETA, PX4, and our national regulator, we organized a live demonstrator in Geneva, the purpose of which was to validate a number of core functions in a fully integrated exercise. And these functions included e-registration, e-identification, dynamic airspace modeling, where various authorities could declare airspace restrictions on a live basis, flight planning, where the drone operators could validate their intended flights against declared restrictions, and the integration of drone position in Skyguide's surveillance data. The reference model was subsequently used by the European Commission for the purpose of designing their own model. It is, of course, being modified and updated through various stakeholders' consultation, which we welcome because the point here is not to be right from the beginning, but really to get the ball rolling. And in the meantime, we have started to work towards the implementation of these core functionalities to develop a UTM system in Switzerland that is already functional for some specific operations, such as the transportation of blood samples between hospitals. So I'll just leave you with a few points as a matter of conclusions, but I'll be happy to develop any of these during the panel discussion. Thank you very much.
All right, thank you, Francis. It's good to see what's going on within one of the states after hearing first about what's happening on a more global basis between the ANSPs. So next we have Mike Lissone. He's the UAS ATM Integration Manager in the Directorate of Pan-European Single Sky at EUROCONTROL. Mike is also the Vice Chairman of the RPAS panel and has been involved with us at ICAO for many years now. So Mike, welcome.
Good morning. Yesterday I was here wearing my JARAS hat, so I'm shifting now to my EUROCONTROL hat. I want to talk more about the IFR challenges we are facing. So looking at this perspective, I would just like to highlight 3 of my concerns, and I presume they might also be the concerns of the ANSPs. I really invite you to completely disagree with me, or violently agree with me, but at least to have a discussion on these points, because not many people are discussing these issues. So the baseline what we have is that the RPAS shall meet the airspace requirements, IFR certified. So if the panel is finished with all the SARPs, and the regulators are finished and the standards are there, can we fly IFR? Is it really sufficient what we are doing now? I must apologize, I don't have any sexy slides with beautiful pictures, just my thoughts on paper, so this is how we move forward. So what are we doing today? We are accommodating. We're doing smart segregation. For Europe, it's more like a bubble around the aircraft, increase separation vertically and horizontally, and thereby avoiding that we close the airspace for a long period of times for manned aviation. And why can we do it? Because we have a relatively low number of mostly military RPASs flying around. And mostly, they're flying outside the route network, as we call this. So we can compare this on the normal routes from Chengdu to Beijing, from London to Frankfurt. They are not occupying these routes. Quite easy, of course. So there are three main concerns, and I'll talk about these very generically. I don't want to go into the C2 lost link part where we still have telemetry, but we cannot control the aircraft. It's just very generic and very high level. So the issue is performance on one side, the performance of the RPAS itself. The contingency procedures already discussed a little bit by Nico, and the separation standards. So here we go. So if we look at the environment we're in now, yesterday Kate said, why does it work? Because all the actors and all the elements inside this aviation system work because we trust each other. And everybody knows exactly what is working. And what is happening now, we're entering and introducing something that has an interesting feature called the C2 data link. And that might also be called the weakest link, if you want to basically be very cynical about it. But for the route network part, it works because everybody is compatible with each other in regard to speed, climb and descent performance, and turn performance. So if we introduce a new RPAS that is not matching the speed and performances of the A320s, the 777s, then this will have a large impact on capacity. It will impact the controller workload. So do we need to set a performance standard on this part? Within EUROCONTROL, we have devised an operational concept, and for IFR we came to two categories. First category basically is the ones that will operate in the route network, and the other ones are the ones that in principle should stay outside the route network. But procedurally, of course, when the times are low, they could enter that part. And then there's this wonderful thing called latency that is also coming around the corner. And I'll talk about the RCP part, the required communication performance, later on when we move forward to the separation standards. So ANSPs need to think about, can we accept IFR capable and IFR certified RPASs with lesser capability that cannot make standard rate turns, that cannot make normal descent and descent gradients, and also in different speeds. Remember, for those who are about my age, when the VLJs came around, the very light jets, the panic we had initially as ANSPs, can we cope with these guys? They're flying just as high but slower speeds. Something to think about. The contingencies part. Well, I've been involved in that part with the ATM working group before I took up the vice chair position. And we came to the conclusion it should be a rare event. We cannot have a loss of link happening all the time. Specifically, if we link this to a special purpose code, that will go off and alert the controller that the link is lost now, not yes, no, all the time, because the controllers will go crazy about that. So we see this as an emergency, because physically you don't know exactly why the aircraft has lost the link. And the other part, of course, the controller can only be the person that confirms that the real contingency procedures, as they are known by ATC, are executed as well. But we need a harmonization on this standard response. At the moment now we have experiences with a lot of military flights from Italy to the North African theater, and there we see a lot of different responses to contingency procedures, and makes it quite difficult for controllers to accommodate these things. Some of them start orbiting, others start climbing, other ones are flying back. For controllers this is simply unacceptable. So we want a standard response. Within the ATM working group we call this our wonderful journey towards this path. Because the ideas are quite simple, but just think about an aircraft departing and shortly after it loses the link. You probably want to hold the aircraft around the airport for it returns, so ATC can get its ducks into a row and get people out of the way. But what happens if the runway changes or the minima changes for the aircraft? So we have a huge amount of obstacles on that side to overcome. Again, is the C2 part the weakest link? You might even consider, in the discussion I had with Varit Sisi when he was still in ICAO, what about automated flights, TBO? Why don't we let them fly from A to B in a fully 4D trajectory flight plan where they can meet these restrictions and can only be interfered with when it's highly required? Food for thought. Separation standards. The SASP provides these, mostly based on areas where there is no radar. But the three main building blocks, comm, nav and surveillance, are the parts where we are there. So if we have a very good communication system where the pilot can respond very quickly to ATC, that is a possibility to reduce separation standards. If we know exactly where he is and the navigation performance is very good, from RMP 01 to 03, then we can also reduce separation standards. And also surveillance plays a very important part in this. But just think about, and Kate mentioned it yesterday, when the link is lost, or that we need to hold reckoning with the fact that the link will be lost. Is this something that will basically change the calculation methodology for the separation standards? Something to think about. And that is all I have to share with you.
Yeah, so we just have to solve the communication, navigation, surveillance, C2 link, separation standards. No problem. All right, next we will hear from Mrs. Catherine Ronfle-Nadaud. She is with the Direction de la Technique et de l'Innovation at DSNA in France. She is also a key member of the RPAS panel, leading the efforts on detect and avoid. So, Catherine, please.
Okay, thank you, Leslie, for the introduction. Thank you to the RPAS panel secretariat for inviting me here, and a great thanks to the Chinese authority for the organization of this event, which is wonderful. I would be better in French, but I will continue in English. So first, I would like to say some words about DSNA. DSNA is the French air navigation service provider, so of course it is responsible for delivering air traffic control services in France and overseas. It handles about 2.8 million flights a year with more than 80 control towers and 7 air control centers. But DSNA also contributes to the definition and upgrade of concept of operations and associated system and services. And this is why DSNA is so involved in the RPAS integration. DSNA has participated as a leader or contributor in more than 70 projects during CSAR Step 1 and 2, so from 2009 to 2013. The challenge now is to go from RPAS accommodation to RPAS integration. Step 1 started in 2013 for us with 2 demonstrators projects, Temperis and Audrea. We performed these projects in tight collaboration with 2 industrials, Airbus and Safran. At that time, in order to comply with the French regulation, we were just able to fly OPV, optionally piloted vehicle. The aim of the project was first to assess RPAS behavior. We started to define normal procedures, then contingency procedure for radio failure, C2 link loss, GPS failure. With Safran, we started to work on detect and avoid procedure and equipment. The output of these 2 first projects were concept feasibility and safety cases, but also it was a very good opportunity to demystify RPAS towards air traffic controllers. And at the end of the project, a lot of air traffic controllers just said, wow, an RPAS is an aircraft. That's true. But the main difference is that the pilot in command is on the ground, so there is a need to define new systems and new procedure. And this is why we continue since 2016 with Step 2, We are participating to the CESAR Industrial Research Wave 1, and we did some live trials with a military RFANG AirPass in order to demonstrate IFR flight plan accommodation. We were able to fly in some operation in Class C and Class D airspace. So why? Because in France, in Class D, all the flights are known because the clearance is mandatory even for VFR flights. So all the traffic was known by the air traffic controllers, and it was possible to provide some separation between all the manned aircraft and the AirPass. During these real flights, we were able to perform multiple handovers. We were able to give ATC instruction and separation to the remote pilot. The AirPass performed standard arrival in Carcassonne, which is an airport, a civil airport southeast of France. And we provided simple contingency procedure for radio failure and C2 link loss. The output of these real flights were more than 30 flight hours. And if you know France, you can see on the map that we started in Cognac, which is a military airport. Then we flew to Bordeaux, which is a mid-sized civil airport. After we flew to Mont-de-Marsan, which is a military airport. Then south near the Pyrenees, and southeast to Carcassonne, again a civil airport. Then north to Limoges. Limoges is a mid-sized airport, and back to Cognac. So that was really interesting to have this interaction between civil air traffic controllers and military one. During this second step, we also performed real-time simulation in Bordeaux TMA. First, we defined operational service and environment for TMA procedures, normal and abnormal. The idea was to use real registered traffic and then to integrate 4 AirPass, one on arrival, one on departure, one on transit, and the last one was performing a specific operation. It was following a car on the highway. And the difficulty is that the highway is very close to Bordeaux Airport. We played the simulations with 25 licensed air traffic controllers, with pseudo-pilots, and with pseudo-remote pilots. Of course, we experiment a C2 link loss, and I will give you some ideas of the procedure we proposed just after. First, we designed tailored procedure for AirPass. So the idea was to have trajectories remaining always in Class C and D airspace, of course, to avoid unknown VFR aircraft. We also propose low arrivals for the AirPass, 2,500 feet, in order to be separated from IFR departure and arrivals. We use reduced to fixed legs in order to avoid noise-sensitive urban area and also to reduce the dispersion of trajectories. For the holding patterns, we used a circular shape holding, first to separate AirPass from IFR, but the idea was also to save airspace volume, because when you just perform circle, you save volume, airspace volume, and also to be more flexible and to help the air traffic controllers to integrate AirPass in the airliners' arrivals, because they were able to put them every 2 minutes. And as you know, for manned aircraft, the holding pattern is 4 minutes. And finally, we propose a specific final approach, steep angle, up to 8 degrees, 14%, and a 1 kilometer displaced threshold, of course, to reduce the final approach time, but also to avoid wake turbulence. So here you can see the procedure. Of course, it's still experimental, but we published all the maps. So on the left, you can see the radius to the fixed leg in order to separate the AirPass to the IFR arrivals, but also to avoid Bordeaux urban area. In the middle, you have a zoom on this approach. You can see that the altitude is 2,500 feet at the beginning, and at the intermediate fix, the altitude is just 2,100 feet. Then you have the circular holding pattern, and on the bottom right, you have the final approach from the fixed approach, the final approach fix to the map. We also proposed a very simple C2-link loss procedure, and the idea was really to keep it simple. So we proposed to put 7600 on transponder and then to continue on the last clearance during 1 minute. So if you compare with IFR, for IFR it's 7 minutes, but because an AirPass is very predictable, it was easier for the air traffic controller just to wait 1 minute. They knew what was going to happen. Then the AirPass leave last level clearance to 5,000 feet. He performed a circular hold of 2 minutes at 5,000 feet and then depart on procedure. The idea was to minimize the time between the failure and the beginning of the final approach, because in Bordeaux we just have one runway in use and you cannot land any airliners as soon as you have this C2-link failure, because if something happens on the runway, it's no more possible to contact and to change the AirPass behavior. Finally, we are just now doing some fast time simulation using EUROCONTROL traffic model, BADA-free, in order to test ACA6U avoidance maneuver in the vertical plan, but also in the horizontal plan, towards manned aircraft equipped with TCAS-1 and TCAS-2, and towards manned aircraft just equipped with Mod S transponder. So we still don't have all the results, but we will come back with that. Next step, we still have a lot to do. So we would like to take the opportunity of CESAR Industrial Research Wave 2 to work on AirPass integration with non-cooperative aircraft, to improve operational procedure and especially for versatile drones operation. We see before this morning that there are a lot of different operations, so flight patterns for AirPass. We would like to work on ground taxiing and airport safety nets. We think air traffic controller training has to be considered for the formation, of course, but also there is a need to update the MANEX, and of course there is a need to take into account remote pilot formation and training. We want to have a tight collaboration with industrial people in order to work on technological logs like C2-link performances and detect and avoid capabilities. So in conclusion, the SNR wants to continue experimentation in order to feed the reflection on AirPass integration and to be able to contribute to all the working groups at ICAO, at JARIS level. We also think there is a need to have a tight collaboration with industrial people to unlock the potential of AirPass. Thank you for your attention.
Thank you, Catherine. So we're really bringing the various pieces together here. We have the ANSPs as a whole that have identified many issues through CANSO. We have Skyguide, who's been looking at this in Switzerland, particularly addressing means of dealing with large quantities of the small unmanned aircraft. And we all know that that is really where the crisis point is around the world. We have EUROCONTROL that has been looking at all sorts of contingency procedures, as well as the communication, navigation, surveillance system as a whole and what it will take. France doing studies on how to bring the various pieces of this together so that we get more information. Now we're going to hear what's going on here in China from Mr. Zhang. I'm sorry, I will end up causing more problems if I try and pronounce this. My apologies. Who is the director of the Air Traffic Control Division of the Air Traffic Management Bureau here in China. Mr. Zhang, please.
Ladies and gentlemen, distinguished guests, good morning. I'm honored to attend the symposium held by the ICAO and Sichuan provincial government. And I wish to take this opportunity to discuss with relevant stakeholders on the issues of unmanned aircraft. Unmanned aviation is an innovative industry. It's applied in industry, in recreation, in sports, etc. There is higher demand, and there is higher demand for and challenges as well for the ATM system for RPAS, especially for the high-speed, high-level RPAS. In the future, we want to integrate manned and unmanned. In the face of ATM in management of airspace, we may need new models. Next, I want to talk about some issues to be addressed when integrating RPAS into the ATM system. Firstly, I want to take some time to talk about ATM B of CAAC. ATM B is a Chinese ANSP. It is under the CAAC for ministering with the different centers like operations, airspace, technical center. We have 7 regional ATM-B, 23 sub-bureaus, 14 ATM stations. We have 1 end control area, 28 control area 2 for the daily aviation. We have at present 15,881 flights daily. Our main task is to implement the relevant rules of CAAC and decisions, directives of CAAC. We also help map out procedures for ATM, promote and map out the development of ATM for civil aviation, provide nationwide ATM CNS information, meteorological information, supervise relevant flight, innovate on relevant technologies and their commercialization as well. In terms of RPAS and its integration into ATM system, we face a lot of problems and issues. I want to talk about the unmanned aircraft situation in China. The emergence of RPAS will challenge the traditional aviation safety and put higher demands on the air navigation service. In the last 10 years, non-traditional aircrafts are seeing increasing numbers entering the airspace, including RPAS. As ANSP, we should know the business demands of airspace users, coordinate their needs to safely use their airspace without damaging other users' benefits, rights. How to orderly integrate RPAS into ATM system? What kinds of issues are we facing? These are some of the concerns for different authorities. Security is the baseline and the priority. In 2017, there were 117 illegal US flights, leading to the avoidance, return, or alternative of many civil aviation flights. To this end, we map out the ATC procedures to US illegal operations in terms of emergency, aiming at reducing the negative impacts of illegal US flights. We want to have a clear procedure for the management and administration of the airspace. At the same time, in Shenzhen, CAAC carried out the Information System Service pilot project targeting the medium small-sized drones in the dynamic supervision, operation approval, information release, operation analysis, etc. The operation of RPAS impact on the manned aircraft system is largely controlled by doing that. Coming back to RPAS, the innovative technology, the performance and many other areas greatly differ from the traditional manned system. How to make it effectively and safely integrate into the ATM system? Relevant stakeholders need to work hard on that. As ANSP, we hope all parties concerned can have harmonized standards and regulation. We are focused on the license of pilot, DAA system, CityLink, the separation standards with other aircrafts, etc. I want to share with you hereby some of the issues and challenges that ATMB of CAAC are facing. The first one is pilot, the license management of pilot. Such management should be similar to manned aircraft. As the practitioner and participants of airspace, the pilots are the essential factors for the safe operation of RPAS. They should, like traditional pilots, follow the basic principles and regulations and bring into full play their professional responsibilities in line with relevant radio terminology, communication principles, so that the pilots can have the situational awareness, especially in the face of emergencies, hazards. They should have coordinated and similar procedures with traditional pilots and communicate smoothly with ATC officers. And the communication channel of RPAS should also be dealt with. In the same airspace and radio frequency, traditionally, the ATCO and pilots can communicate directly and send information to each other and have shared situational awareness so that the traditional pilot can cooperate better with ATCO. However, for RPAS, they have fixed routes generally. The movement of RPA, the rules of communication will be different from traditional air-to-ground communication in the manned system. Therefore, remote pilot and the traditional pilot, how to ensure the situational awareness between pilots and ATCOs is something I'm highly interested in. I believe these concerns are also the concerns of pilots. The second issue is DAA. All RPAS that plan to integrate into ATM system may be confronted with manned aircrafts, so they should have a set of DAA system to make sure that they can be detected between RPAS and manned aircraft. And in emergency, they can avoid each other in a timely manner. And this shouldn't be rely on CityLink. Even when CityLink fails, we can still have the effective and timely DAA. For RPAS DAA, whether we are able to make pilots on the ground to have the similar kind of sense of sight listening with traditional pilots. This is something we need to consider. We will need to look at the proactive detection and avoid hazardous meteorological conditions, ground activities, obstacles, and other up-air issues. Another challenge is CityLink. CityLink is important for monitoring or communicating of the information of RPAS, and it's an important connection and linkage for voice communication and data communication. And CityLink's performance in anti-interference hijacking prevention should be given priority. Once CityLink failure, there needs to be auto-navigation procedure. In terms of integration, RPAS should be equipped with corresponding CNS. Different from manned aircrafts, the remote pilots are on the ground. The communication system can be done in various forms by using telephones, like very high frequency. These channels need to be further clarified in the future. Another thing is air traffic controller. When RPAS is operating, for air traffic controllers, I believe they would hope there wouldn't be much difference with existing regulations for them. But of course, they would like to have manned aircrafts. When we are integrating RPAS into the ATM system, the controllers need to adapt to new things, new technology, new regulations. In terms of RPAS structure, the framework, the operating characteristics, etc., they need to receive relevant training in these aspects so that RPAS can better integrate into the ATM. We will continue to support and participate in the relevant symposiums and in the regulation rules in the future. Thank you.
So now that we've heard from all 5 of our speakers, and there have been some common threads throughout these about the predictability of operations, the training for controllers as well as pilots so that there's an understanding of what is going on, the equipment requirements, communication, navigation, surveillance in particular. So we have various questions that have come in, but before I get to those, I'd like to just get a sense between the 5 of you. If there are particular approaches that you think that are working very well, or where we still have gaps in terms of the interaction between the air navigation service providers as well as the operators, the industry, who are trying to introduce all of these new operations into our otherwise very stable, predictable world. So is there anything that you would say, Nico, in terms of what is working well with the outreach to industry versus things that need to be done a bit more effectively?
I think if we listen to all the presentations, we see that it's not happening on a very frequent, it's not happening very frequently yet. I think what we do not know yet is what kind of capabilities, performances, what is the need to be integrated. Is there a need to be integrated? Could it be completely segregated? I think we still don't know exactly what we have to expect. When we have at the moment that sometimes an RPAS going through our system, it's so rare that we can cope with it. But I think we have to be more proactive in looking what is coming to us and what do we really need to integrate and what do we need to segregate.
Well, as far as I'm concerned, we distinguish these two levels, the low level and the share level of the airspace. Regarding the low-level part of the airspace, it really requires a dialogue with the industry to understand the needs, and also a discussion with the regulator. To be very honest, we're becoming a little impatient because you mentioned that too, Leslie. The incidents that we experience are in the lower part of the airspace. So we really see here the need to take regulatory action to get away from this blanket 5-kilometer rule that doesn't help at all and is not enforced. We find it easier to discuss the issues in the shared part of the airspace because we're dealing with, I would say, a more disciplined community. Here it is a more rational approach to the matter.
Thanks, Leslie. Good question. I think what I find very encouraging is in the RPAS panel that we have quite a lot. I think we're the largest panel with more than 100 people there. A very wide spread of the aviation community, so that makes it very easy to talk with a lot of people. What I find very difficult is, what I mentioned yesterday, is the fact that there is no real common understanding on the issues. I mean, I brought some of the issues forward that I think might be interesting or not. A lot of people haven't thought about it. We have incidents around airports with drones, and talking to the states, most of the states don't really know how many are operating there. So I think we really need to start working on the integration challenges, but also have feedback from companies like UPS. What are their plans? What is really going to happen? Because we need to start adapting to that part and stopping to pick up the pace.
Yeah, thank you for the question, Leslie. I think it's really the good one. My feeling is that up to now, perhaps we distinguish too much what we need for the systems themselves and the operational procedure we could build. And my feeling is that we need to put them together. We will not have perfect system, for example, when it comes to detect and avoid, so able to completely replace the pilot on board to see and avoid and to have the best awareness of the situation. So we need to develop operational procedure in order to put them together with the system itself. And if not, we will really have a highly costly system, too costly, and we will not be able to fly them among the manned aviation. This is really my feeling, and we need to work on that right now.
那个应该说，那个从无人机的发展，今天就是互动的一种。我们这次全球无人机大会之间的。
Between the two, I think this is a very good forum. For the development of drones in China, we have similar problems. In the process, in the application, we have huge demands, and now we are taking our first step in a segregated airspace and low space. These are the places where the major operations are happening. Just now I mentioned that in Shenzhen, we had similar systems to promote the development of drones, but in the development of drones, it is influencing and interacting with the current regulatory system. This is the biggest challenge we're facing right now. Yesterday, we heard about thoughts on the classification, and in China, we classified by weight in terms of the drones. But for this model, it may not persist in the future. Is it feasible in the future? It remains a question. So this is the, yesterday we heard about the ABC classification from the ICAO. I think this is very helpful for us. This is a great concern for the industry and the regulator of drones. So I think Class C, that is the classification, will be a major challenge in the future and a major concern for us. Thank you very much.
Yes, thank you. And now we're going to get to some of the questions, because quite a few have come in from the audience. And I'm going to put one back to Mike. He's already addressed this a little bit, but he can expand upon it. And the question is the ICAO RPAS panel assessing RPAS C2 link failure conditions for integration purpose airworthiness certification? So this takes it a little further than just simply what is the contingency response from ATM.
The panel is addressing that part. That is, of course, the normal airworthiness approach to these elements that are there. I don't think the elements in there are going to be quite difficult. It's going to be a very high requirement on the C2 link part, which is going to be quite interesting for the provider of the C2 link to have this fail-safe link that will only be there in most of the times. I think the most interesting part will be that we are going to work beyond ready line of sight, where we'll use satellite communications, satellite parts, where we have a longer trajectory on that part. And what I forgot to mention really clearly in my presentation is also that we need to start thinking about the required communication performance, which is also a very big part of the C2 link. And within the PBN part, there is 2 PBN specifications where there is a required communication performance. That actually means that the transmission from ATC until the execution of the order of ATC is defined in a certain time. And that basically makes it sure that you can basically adapt these parts to separation standards. Now, for ATC with manned aviation, specifically in terminal airspace operations, these have never been defined because they've grown over time. If you're operating in an environment like Heathrow, you know, with high intensity runway operations, that everybody will answer these things very, very fast. But if you have somebody in there with a latency part that cannot respond immediately, and there is a latency part on that part, this is going to be the elements are there. So I hope I answered.
Would anybody else like to contribute to that?
I would just add something, because there is a working group at in the RPAS panel in charge of this problem, of course. But my feeling is that in the future, we will have to find a compromise between the requirements we are going to put on the C2 and the level of autonomy of the drone itself. So up to now, it's difficult to propose something that probably, and I'm also thinking about the detect and avoid, of course, the level of autonomy we will be able to put on the detect and avoid will help to manage the requirements for the C2. And again, I repeat, the operational procedures we will be able to define will also help.
All right, I have one here that we will start with Nico on. And it's about using the existing aviation CNS infrastructure. And is this seen as being appropriate for the long-term strategy for successful integration of RPAS? Or is this simply the near-term fix to address integration? So with the existing ATM CNS infrastructure.
I think at the moment they have to be using the current infrastructure because you cannot change the ATM system to accommodate the new entrances directly, especially not worldwide. Do we need innovation to change it? Yes, perhaps in the future. But to integrate them now in a system that is working and working safely, they need to adapt to the system that is there.
Well, our assumption makes a difference precisely between the different layers of the airspace. In the airspace that will be shared by manned and unmanned aviation, where you'll have drones that really behave like ordinary aircraft, then our assumption is that the CNS ATM infrastructure in place will do the job. But when you get to the lower level of the airspace, because of the nature of the business, our assumption is that we should not develop a dedicated infrastructure for that, that it should be based, for instance, on the use of mobile phone networks. And for instance, also as far as onboard equipment is concerned, some of the classical ATM devices may be too heavy for these drones, and you'll have to have light forms of technology that meet the standards.
Thanks, Leslie. Another interesting question. I think I'll go the same way the previous answer went. I mean, for IFR, I think it's sufficient because the numbers are relatively low. For the lower airspace, the UTM part below 500 feet, I think there lies the challenge. If we want to use ADS-B mini transceivers and stuff like that, then the 1090 frequency that we're using in Europe is simply not sufficient. This is already stretched to a certain part where we have too many interrogations. So we'll have to find new parts. So I think on that part, the existing CNS infrastructure will not suffice.
Agree to what was said before, and I would like to highlight the fact that even in the existing ATM, we have this controlled airspace part, but also the uncontrolled one. So my feeling is that it's mainly for the uncontrolled part that we have to invent something new in order to be able to accommodate or to integrate other UAs, because in fact we just have one sky.
我也非常赞同前几位专家所提的。
I quite agree with the speakers. I think for the we need to differentiate between the low altitude and high altitude, and the controlled and uncontrolled part. That is for the segregated part. There might be a system that is different from the current ATM system. I think at the same time, especially for low space, in the control of commercial aircrafts, we need to use the current 5G or 4G technologies, like the mobile phone network. Otherwise, it will increase the cost significantly.
Very good, thank you. Now I have one question here that I'm quite interested in hearing the response myself, which is integration the answer for all RPAS and UAS? Or will we see a more fragmented accommodation, segregation, integration, depending on operations and characteristics? So is this going to be seen as a one-size-fits-all from the ANSPs, or are there flexibilities for different types of operations? And I think we've already been hearing some of this, but I'd also like to throw into the mix on this the very high altitude. We've got the low altitude, the very high altitude, and all the airspace in between that is shared. How many different approaches can we do? Or rather, can you do as ANSPs?
I think if we talk about integration, it will mean that they use the same airspace and need the same level of safety. If you speak low space, then there is no commercial aviation. They can define the RPAS or the UAS that's starting to work there can have their own segregation or separation from each other. As soon as it comes close to controlled airspace, there has to be a sort of integration coordination. And I think we talk about that later in the week when we talk about drone enable. That will become more prominent in forward. If you talk about the high level compared to the very low level, the difference is that to become high, you have to go through that intermediate space. So there is always a sort of integration or separation. So I think we have three systems. There doesn't have to be an integration on the very low level because they're separated from the commercial aviation. You have the middle area where everybody is flying on IFR, VFR rules, and they have to be working together and separated from each other safely. And you have the high level where you have to take care of the process from the ground until high, and then you have to find something how all those high traffic is separated from each other. So yes, you have different systems depending on the sort of operations and where they are.
Well, the ideal vision should be that in the end there is a full integration of all drone activities, but it's not going to happen overnight, and there are going to be several integration paths depending on the operations. We believe that some of the drones will blend more easily in the manned aviation than others, precisely those that can behave like ordinary aircraft. And it's going to be a matter of technology. As technology allows the blending of these drones, and for instance, in the end, if the air traffic control system doesn't even have to bother knowing that there's a drone in the airspace, then it can be fully integrated.
Another good question. I can only echo what has just been said. I think if you look at the basics, the FIR is managed by the ANSP. So on that part, I think the ANSP plays a very important role to at least have the overview. I think as innate technology will evolve over time, that will basically allow the integration more. But if you already talk about where we see two categories of RPAS operating in the same airspace, it's about, let's say, a play of words. It could be seen as integration. It could also be a smart way of segregating the part. For the high-level part, that is the part where we expect industry to provide the separations. That's going to be the interesting part, but they, like Nico says, they will have to transit through the normal airspace part, so I think it will be a stepped approach.
Yeah, of course, agree with the previous answers, but I think ANSPs already know how to provide different services, because today, for manned aviation, we are not providing the same service for an airliner and for a glider. So we already know how to propose different services at different costs. Of course, we need to improve the system themselves in order to increase the conspicuity of all the UAS for all the airspace users. For me, this is something like the key.
As part of ANSP, and as a controller, I feel that the integration of RPAS should consider the different types of RPAS and different airspace, whether it's just commercial or consumer, or whether they are operating in the specific controlled, segregated or non-segregated airspace. We may have to consider their workload on controllers and on efficiency and safety. Well, we need integration in the long run.
Yes, I fully agree with all of those. So there's a lot more work to be done. Now, I think we have a lot more sharing of information that needs to be done. So the ANSPs reaching out, getting more information back in from operators, as well operators spending time learning what the requirements are from the ANSP perspective, because You will not be operating in a vacuum. You are operating in a very well-organized environment. But it is an environment that addresses many types of aviation already, many types of aircraft doing different types of operations. So ANSPs do have a lot of flexibility. But at the same time, there's a lot of training, a lot of knowledge that is needed on both sides. So this will be an ongoing open discussion between the parties. And I encourage all of that to continue during the lunch break. But first, please join me in thanking all of the panelists for the very informative session that we've just had. And with that, I will save Phil the effort of having to come up here and say, we have lunch, again, down by the poolside and in the pavilion. Please be back at, of course I didn't look at that part, 2 o'clock. Everybody, please be back at 2 o'clock. Speakers for the next session, be back just slightly ahead of that, please. Enjoy your lunch. Thank you.